prefix co mean? Like together, right?
Yeah.
Like if you cohabitate, you're living with somebody, yes? Yeah, like co-owners own it together, yes? So then the other part of that is terminal, which I think we talked about a little bit, but I don't know if I actually like wrote it out for you. So we have two different sides for an angle. The first is the initial side. Initial also meaning like starting. And the second is the terminal side, meaning ending. So our initial side is the side that lies upon our x-axis. Your terminal side is the one that's going to rotate. Alright, I'll go through there. So looking at context clues, what do we think coterminal angles might have in common?
They're both not the initial side.
Okay, so something about the terminal side. So co meaning together, terminal meaning the terminal sides. What do we think they might share?
Being terminal sided.
Yeah, so it is two or more angles that share a terminal side. Yes, well, maybe. And there's a couple different ways that they can do that. So first off, we said that how do we rotate when we are rotating in standard position? Counterclockwise. And that is a positive angle. However, we can rotate clockwise. We just have to have the negative angle there instead. So that positive and negative angle, notice, end at the same spot. So they would be coterminal angles. Yes? Okay. Another way that this can happen would be, let's say I have an angle in my first quadrant, right? So I just go there. Yes?
Mm-hmm.
But what would happen if I go all the way around and back there? Do they still end at the same spot?
No. Yes.
Yes, they end at the same spot, right? I just went one full rotation and then a little bit more, yes?
Yeah.
So how many degrees are in a full rotation? 360, yes? So like one full rotation is 360 degrees. Do you have any of us that like skateboard or snowboard?
I skateboard.
Okay. So are there tricks out there that are bigger than 360 degrees?
Yeah.
Yeah, it just means that you have to do one full rotation and then you have to keep going, right? Same thing with like snowboarding. You can make one full rotation and then keep going. So for our angles, we tend to write things that are in the first rotation just because they're smaller numbers, but we can always keep rotating if we want to. Yes, no, maybe.
Mm-hmm.
Okay, so let's look at an example. I have 130 degrees. So let's first figure out where is 130 degrees. So what angle is my positive y-axis? 90, okay? What angle is my negative x-axis?
180.
180, okay. So where would 130 have to be?
In that first quadrant.
In
Second
the second quadrant, right? Okay. What is exactly halfway in between?
135.
135. So is our 130 going to be pretty close to that?
Yeah.
Mm-hmm.
Yeah, which is why we like standard position. Because, like, did I have to bust out my protractor? But that's going to be a relatively, that's going to be pretty close, right? Because I know exactly halfway in between is 135. 130 is going to be pretty close to that. So as long as I'm drawing it in standard position, I can get relatively close. Yes, no, maybe.
Mm-hmm.
Now it wants us to find one positive and one negative. So this is 130. So let's start with the positive. How might I find another positive angle? What did we talk about?
Radians?
So we still want to be in degrees if they give us a question in degrees. We'll do radians here in a second. But what did we talk about that we're able to do?
Go all the way.
Go all the way around. Okay, so if I want to go all the way around, but still end up back there, how would I find what that angle measures?
360 plus 130.
Yeah, so I can take 130 and add 360. And what do we get?
130.
Agreed. Now, let's say, instead, so this is still my 130. How would we get our negative angle? We go, right? Go clockwise instead? Alright, how would I find that?
360 minus 130.
You sure? What is 360 minus 130?
230.
Okay, but what kind of angle am I supposed to get?
Negative.
Okay, is that an angle?
Negative.
Okay, so what would I have done instead to get that?
130 minus.
There you go. So instead, I want to take 130 and subtract 360. And we do get negative 130. Negative 230.
Yes.
This one maybe? We okay with that? Yeah? So in general, notice that if I want positives, I'm just going to add 360. If I want negatives, I'm just going to subtract 360. And that is always going to work. So I'm going to add or subtract 360. Someone mentioned radians. What is 360 in radians? 2 pi. So we can also add 2 pi. So those are our formulas. Add or subtract 360, add or subtract 2 pi. Now, are those the only coterminal angles? Could I add 360 again? Could I add it again? And again, and again, and again. And as many times as we wanted? So there's technically an infinite number of coterminal angles. So if, you know, you want to be a jerk, you could like add it 5 or 6 times and get some huge angle that is technically a coterminal angle. Usually we just start with the first one and we add or subtract it one time, but you can add or subtract it as many times as you want. Okay. Now, speaking of, let us find our coterminal angles, but in radians instead. So the process is going to be the same. Still wanting to find either the negative angle that's going clockwise instead, or I'm wanting to add a full rotation. So I'm still just adding or subtracting, but now since we're in radians, we want to do the process in radians, which is 2 pi. So, it doesn't specify for this one if we want a positive or a negative, so we can pick. We want to find a positive or a negative for the first one. Positive, sure. So we'll find a positive coterminal angle. So that means that we're going to do what?
Add 360.
But we're in radians, so instead it's going to be 2 pi. So we do have to find a common denominator. But what's nice is what's the denominator of our second? 1. So what's the common denominator between 6 and 1? 6. So we're going to multiply our second by 6 over 6. So we get 12 pi over 6, which gives us 25 pi?
Yeah.
Over 6? Yes, no, baby? Alright, so let's say I wanted to find a negative coterminal angle for our second one. What would we need to do this time?
Minus 2 pi.
Ah, okay. Am I still just finding a common denominator? that's 4, right?
Oh, I'm so smart.
So 8 pi over 4. So what do we get?
Negative
-5 pi over 4.
Agreed. Yes?
Mhm.
Yes. Alright, so for the last one, I want you to find one negative and one positive coterminal angle.
Wait, what did it do?
Can you read a bigger pen?
Maybe.
So,
So we went to 3, we have to multiply the top by 2. So this piece is right.
what?
The other bottom.
We're not trying to find that, we're trying to find the coterminal.
On the bottom? 3. Negative 2 pi over 3.
No, I had worked it out.
Or there's also that table of front. Alright, so yeah, we are adding and subtracting 2 pi again. Our common denominator this time is going to be 3. So we end up with a 6 pi over 3, right? So if I add that, so negative 2 pi over 3 plus 6 pi over 3 gives us a positive 4 pi over 3. If I subtract it, we would get a negative 8 pi over 3. Okay? So again, just adding and subtracting fractions. If you're ever stuck, realize that, again, these are just fractions. So like you can always just take like negative 2/3 and add 2 in your calculator, and then just put the pi at the end. And that'll give you the same thing. Okay? What questions do we have there? So are we okay with coterminal angles? So sometimes depending on the problem, we might want the negative angle, or if we're given a negative angle, we want the positive angle, or sometimes we need a bigger angle, so we add 360. So coterminal angles are just helpful depending on what type of question we have. The other thing that's helpful is going to be our reference angles. So when we were looking at our unit circle, we built out a bunch of angles around it, right? And we said those are the angles that are going to come up really often. Yes? We also said that we're going to need to memorize, or at least know how to find all of the parts of our unit circle. And so really it's helpful, we really just want to memorize the first quadrant, because we don't want to have to memorize all the parts of the unit circle, because that's a lot of numbers. So if there's a way that we can just memorize the first quadrant, that's real helpful. And so that's where reference angles come in handy, because reference angles let us take some of those bigger angles, like in our second, third, and fourth quadrant, and refer back to, or reference back to, the stuff in our first quadrant. Does that make sense? We're with me? Because we're going to find some more stuff like sines and cosines and things like that. We don't have to want to memorize all the angles, we just want to memorize the ones in the first quadrant. So we're going to have to find a way that we can refer back to our stuff in the first quadrant. So when we are in the first quadrant, what type of angles do we have there? They are positive. These are technically all going to be positive.
30, 45, 60, 90.
90 is not in our first quadrant.
40.
The first three were though, right? So all three of those would have to be smaller than 90, which means that they are acute. Have we all seen this symbol before? It's a theta. Okay, so theta is a Greek letter. Okay, it is a variable, just like x or y is. But we tend to use Greek letters when we are looking at angles. So it just basically means the angle. Okay, it's just a variable to represent the angle. And when we represent reference angles, we're going to call that theta prime. So in our first quadrant, because we already have acute angles, then we want acute angles. Okay, it just equals itself. So acute angles is the first requirement. Okay? Because then, if we're looking at my second quadrant, so this is quadrant 2, do we have an acute angle in our second quadrant?
No.
Is that angle an acute angle? No. Okay. It's an obtuse angle now. Well, we want to find the acute angle that kind of references, again, we want to reference one of our first quadrant angles. Now, if we recall back to some of our previous information, yes? When we find trig things, what type of shape do we tend to use a lot? Triangles, which is why they have the same prefix. Okay? So notice that we could build a triangle in our first quadrant. Yes? Yes or maybe? Okay. So notice that pretending that like my orange angle and that this blue angle, say that they're in the same spot in the first and second quadrant, okay? Would we agree that if I drew a line there, does this orange triangle equal my blue triangle? Yeah, it's just been reflected. Agreed? But like all the side links and stuff like that would all be the same. And so that's the part where we're going to be able to refer back to, okay, is that these triangles, as long as my triangles are the same, all the other stuff is going to be the same. So what that means is we need to be able to find what this little angle right there is. So what's an angle that's in my second quadrant? 120. Okay. So if this was 120 degrees, okay, that's my blue angle. How would I figure out what my little orange angle is?
180 minus 120.
Yeah, 180, because that's the first top half, minus 120, because that's what my blue angle would be, would just give me whatever my little leftover slice is there. Yes, which in that case would be 6. Yes? And that's going to work no matter what your angle is there. So we will take 180 and subtract off our original angle, and that gives us, again, remember this just means the reference angle. Yes, no wait. Okay. So then continuing on, let's look at our third quadrant. Okay. Now we do want to be careful here. So it has to be an acute angle. It actually has to be the acute angle formed between the terminal side. So remember, that's the one that rotates. And remember, I said I want my little triangles to be equal. And the only way that our little triangles can be equal is if we make our little triangles with the x-axis. So that means that on this one, my reference angle, or like the part that we would form our little triangle with, is going to have to go to the x-axis still. Because a lot of people want to go to the y-axis. But our triangles are only going to be the same if we always go to the x-axis. So So what's an angle in our third quadrant? 240. So if this was 240 degrees, how would I find the orange bit? So if I take 360 minus theta, that would give me this leftover part on that half. It has to do with 180, I agree. Well, we already did 180 minus theta, John.
Is it 240 minus 180?
Yeah, it would be our angle, so we said, I think we said 240, right? And so that's going to be this whole thing, but then remember the top half is 180, so if I subtract that part off, I'm just going to be left with the little piece afterwards. And so that's going to work no matter what our angle is. So this time we take theta, and we subtract 180. So then lastly, we have our Pac-Man piece. Right, doesn't it kind of look like Pac-Man? Yeah. So again, we have to go to the x-axis. So this time we're trying to find what the little Pac-Man mouth is. So how would I, what's something that's in my fourth quadrant? 3 what? 323 would be in our fourth quadrant. Okay, so if that was 323 degrees, how would I find the little leftover bit?
That minus 240. Or 270.
So if I took my theta and I subtracted 270, that would give me the piece that goes to 270 instead. There we go. So we want to take the full rotation, which would be it like including my orange, and we just want to subtract off all the other stuff so that we're just left with the orange part. Okay, what type of angles were all of those? Or my 180 and 360 are all in what? So all the angles that we gave were what kind of angles? They all have a what at the end?
Degree.
It's a degree. Are those the only type of angles that we have? No. Now we also have what?
Radian.
Radians. So if something is given in radians, we're going to take pi minus theta, or theta minus pi, or 2 pi minus theta. Because again, if it's given to us in radians, we're going to calculate stuff in radians. We're not going to spend the time converting back and forth between the two. Alright, what questions do we have there? Look at an example. We talked about some examples, but let's look at some like actual ones. So on my first one, it says we have the angle of 300, and we want to find the reference angle. So what quadrant is 300 in? The fourth, because it is bigger than 270, but smaller than 360. So how do we find that one? Remember that would give us this piece right there. We have to go to our x-axis. So we're going to take 360 and subtract our 300. What do we get? 60 degrees. So our reference angle would be 60 degrees. Alright. Now, where is part B? What quadrant is that one in?
2.
So this time, what are we doing? Except we are in radians, so 180 in radians is pi. So I take pi minus 2/3 pi. Yes?
Yeah.
So what's our common denominator? just a positive, but yes, pi over 3. And that's also nice, because if you look at your unit circle, okay, any of your radians on your unit circle are always going to have a reference angle of whatever the denominator is. So if I have 3 pi over 4, that would have a reference angle of pi over 4. If I have an angle of 11 pi over 6, that's going to have a reference angle of pi over 6. Because when you find those common denominators and subtract, you're always just going to end up with pi over 3, pi over 4, pi over 6. So that is one of the nice things about your unit circles. Alright. What's tricky about this last one? It's negative this time. Okay, so that means that we're rotating clockwise. So positive 135 would be in what quadrant? The second, okay. So we're still going to be in the second quadrant, but we're going to be in the second quadrant going clockwise. So it's technically our third quadrant. Are we allocated with that? But again, our reference angles have to be acute angles, which means that they have to be between 0 and 90. So we have to get it to be positive first. So we need to find the what? What did we talk about earlier? The coterminal angle. So we're going to find that coterminal angle first. So what's negative 135 plus 360?
255? Wait, no, 225.
Do we agree?
Mhm.
Okay. And then from there, now we can find our reference angle. Okay. So if I'm in my third quadrant, how do I find my reference angle? 225 minus 180, which gives us 45 degrees. And that would be our answer. What questions do we have there? Alright, that's where we'll stop for today. Tomorrow we're going to remind ourselves about our trig functions. So sine, cosine, and tangents. And then we're also going to start adding those like coordinates to the outside of your unit circle.
Right, so basically you go